Good afternoon, class. We're looking at chapter 6, periodic / trigonometric functions. We're going to look at 6.1 and 6.2, more graphs of trig functions with the phase shift sinusoidal curve fitting as well. So what are we going to cover? What is the objective graph sinusoidal functions of the form y equals a sine omega x minus phi plus b? And you can take the omega out, a sine omega times x minus phi over omega plus b, same thing for the cosine, and build sinusoidal models from data. And so, again, reminding you of what we just looked at, in order to graph sine and cosine, we cut the period of 2 pi. We are looking at a complete cycle. We cut it into 4 pieces, and we graph the end points. Those are the 5 key points. That becomes a sine, 0, 0, pi over 2, 1, pi 0, 3 pi over 2, 2 pi 0, and we repeat the same thing for cosine in the same manner. And of course, notice sine is cosine of x minus pi over 2, and you go indefinitely on both sides. Also, if we have y equals a sine omega x or y equals a cosine omega x, then the period is 2 pi over omega, amplitude is the absolute value of a. Graphs of tangent, cotangent, cosecant, and secant, we are familiar with at this point. Y equals tan x. Pay attention to the fact that tan x is sine over cosine. Therefore, if you want the domain, cosine can't be 0. And if you set equal to 0, becomes the vertical asymptote, t equals pi. Cotangent, notice is cosine over sine, and we have the same t pi. So now, if you want the vertical asymptote, the denominator sine x equal to 0, x equals n pi. However, the domain x can't be n pi. The intercepts, cosine is 0, 2n plus 1 pi over 2. And to graph cosecant, okay, you can graph the sine and then flip it over. Cosecant is 1 over sine. So x can't be n pi. Again, you can use the same methodology to figure out the domain, range, vertical asymptotes. And in the case of a secant, secant is 1 over cosine. And pay attention to the denominator cosine, where it's 0 would be the vertical asymptote, where it cannot be, gives rise to the domain. So this is the synopsis of what we've covered in the previous section. And now, phase shift, short PS, sinusoidal curve sketching. Graph sinusoidal functions a complete cycle where y is a sine omega x minus phi, and we are assuming a, omega, and phi are positive. Okay, so a complete cycle, because there is a phase shift, okay, it's you divide by omega. Okay, let's just write this in general. The period is 2 pi divided by omega. And by the way, take the omega out, as it is the case here. It's been taken, so you can see the phase shift of phi. This is phi over omega. Both are Greek letters, okay? And if phi is negative, phase shift is to the left. If it's positive, phase shift is to the right. And in some text, they use just ABCD. Y equals a sine of parentheses bx minus c plus b. So it depends on what text you're using. They all mean the same thing as far as the concept is concerned. So you start from the phase shift and you go a complete cycle to a period of 2 pi over omega to the right, and you can graph this again by coming up with 4 arcs. How do we do that? Steps for graphing a sinusoidal function of the form a sine omega x minus phi plus b, the same thing for cosine, using key points as follows. Step 1. Determine the amplitude A, absolute value of A, period t equals 2 pi over omega, and phase shift pi over omega. Step 2. Divide the interval with the starting and the ending points of one cycle, phi over omega and phi over omega plus 2 pi over omega, into 4 subintervals of the same length. Step 3. Use the endpoints of the subintervals to obtain the 5 key points on the graph, just as before. Step 4. Plot the 5 key points and connect them to obtain the graph of one cycle. So that's a complete cycle. Now extend on each side to make it complete. If b is not equal to 0, apply a vertical shift. So in other words, do this one at the end, go up and down, whatever the value is. Positive, take it up. Negative, take it down. That's one way to do that. So here's a simple example. We're going to find the amplitude, period, phase shift, and everything else for this function y equals -2 cosine of 4x minus pi. So how do we do that? The very first thing, class, x inside the parentheses must have no coefficient, so 4 comes out. So if you put the 4 out, in other words, if you factor it, this becomes x, this becomes minus pi over 4. So that, please understand what happened here. You take the 4 out. If you multiply the 4, you get 4x minus pi. So the amplitude is the absolute value of -2. T is 2 pi over omega, 2 pi over omega. This is omega, 2 pi over the coefficient of x. So 2 pi over omega, 2 pi over 4 or pi over 2. And so if the period is pi over 2, a complete cycle goes from 0 to pi over 2. Now going back here, if you look at this one, this is the phase shift. When you take the omega out, this is the phase shift. If it has a negative, that means positive. So pi over 4 is the phase shift. And if that is the phase shift, and this is a complete cycle without the phase shift, now you have to add this to this. And in other words, from 0 to pi over 2 shifts by pi over 4. Originally, we would be here, but we are shifting it by pi over 4 because the phase shift is pi over 4. And so you add it to 0, you get pi over 4, pi over 4 plus pi over 2. Pi over 2 is 2 pi over 4, and pi over 4 is 3 pi over 4. So this is the cycle. So we are going to go from pi over 4 to 3 pi over 4. And so now we're going to cut this into 4 pieces. So we're going to divide the t by 4. The t was pi over 2 divided by 4, you get pi over 8. And so pi over 4 to 3 pi over 4, we start with pi over 4 and we add pi over 8. So when I add pi over 8, remember pi over 4 is 2 pi over 8. I get 3 pi over 8. Then I add pi over 8, I get 4 pi over 8, which is pi over 2. Then I add pi over 8, I get 5 pi over 8. And then I add pi over 8, I get 6 pi over 8 or 3 pi over 4. So let me quickly recap. We are adding pi over 8 to this number. We get 3 pi over 8, and we keep on adding pi over 8. It gives us these 4 subintervals. So from pi over 4 to 3 pi over 8, from 3 pi over 8 to pi over 2, pi over 2, 5 pi over 8, 5 pi over 8 to 3 pi over 4. Now we plug in the endpoints. For example, pi over 4, if I plug in, I do a couple of them and then the rest of them is. If I put pi over 4, four times that becomes pi. Pi minus pi is 0. Cosine of 0 is 1 times -2 is -2. So the first one would be the pair power 4 and -2. So that's one of. If I put 3 pi over 8, let me just show you 3 pi over 8. If I put 3 pi over 8, and I'm going to write it here and then I'm going to erase it, -2 cosine of 4 times 3 pi over 8 minus pi. Three pi over 2 minus pi is pi over 2. What is cosine of pi over 2? 0 times -2 is 0. Pi over 2. Let me erase the work first. If I plug in pi over 2 as an example, what is 4 times pi over 2? 2 pi. What is 2 pi minus pi? Pi. What is cosine of pi? -1 times -2 is +2. So you have these pairs. I hope you can see that you can easily evaluate the pairs. So now we're going to put the pairs here. By the way, this is pi over 2. Okay. This is pi. This is 3 pi over 2. This is 1, 2, and so forth. By the way, it's not to scale by any means. So pi over 4, -2. So this is pi over 4. This is -2. Okay. Now pi over 2, 2 is here, everybody. And 3 pi over 8 is in between. So it's in between. It's hard to see. And pi over 2 is 2. Pi over 2, 1, 2. 5 pi over 8 again is in between. And 3 pi over 4 is this one. So it looks like this. Now you go indefinitely on the right and left. That would be the graph. Okay, so that's how you do that. What about this function, y equals 3 sine of 2x minus pi, and we want to do the same thing, and the very first thing, we take the 2 out. So 3 sine 2 times x minus pi over 2. So the amplitude is 3 because absolute value of 3 is 3. T is 2 pi divided by 2, which makes it pi. And instead of 0 to 2 pi, we're going to go 0 to pi. However, there is a phase shift of pi over 2. So we need to add pi over 2 to this. Because of the phase shift that has been shifted to the right, we're going to move this to the right by pi over 2. We get to add this one, we get pi over 2, and this becomes 3 pi over 2. So I hope everybody can see how we do that. So basically, a complete cycle that is normally 0 to 2 pi has been shifted according to what we just did. Now, we're going to cut the t into 4 equal parts. And this interval, we start with the first point. We add pi over 4, and then the next one pi over 4, and so forth. So for example, so because we want to cut it into 4 subintervals, you add pi over 4, Remember, pi over 2 is 2 pi over 4. You get 3 pi over 4. And then you add pi over 4, you get 4 pi over 4 pi. You add pi over 4, you get 5 pi over 4. You add pi over 4, you get 6 pi over 4 or 3 pi over 2. So those are the ones. So again, you start with pi over 2 and you add this pi over 4, you get 3 pi over 4. Now from here, you add pi over 4, you get pi. From pi, you add pi over 4, you get 5 pi over 4. Here you add, and now the endpoints, we are going to have the following 4 subintervals. The subinterval of pi over 2 to 3 pi over 4, 3 pi over 4 to pi, pi to 5 pi over 4, 5 pi over 4 to 3 pi over 2, and those are the endpoints. We're going to make up the key points as follows. So plug in pi over 2 here. So if I put pi over 2, I want to show you how easy it is. If I put pi over 2 here, I get 3 sine. Okay, pi over 2 becomes what? 2 times pi over 2 is pi minus pi is 0, and that is 0. Okay, if I put 3 pi over 4, I get 3 sine 3 pi over 4 times pi 6 pi over 4 minus pi. 6 pi over 4 is 3 pi over 2, and 3 pi over 2 minus pi is pi over 2. Sine of pi over 2 is 1, so you get 3. You can put 3 pi over 4 times 2, you get 3 pi over 2. I just did that, I mean pi now. Let's, the one I didn't do is pi. So plug in pi. 2 times pi is 2 pi. 2 pi minus pi is pi, sine of pi is 0. So pi gives you 0, and I'm assuming you can figure out the rest. So a grid, pi over 2, 0, 3 pi over 4, 3, pi 0, 5 pi over 4 minus 3, and 3 pi over 2, 0. So those are the points. Pi over 2, 0, 3 pi over 4, 3, pi 0, 5 pi over 4, negative 3, 3 pi over 2, 0. Here's one cycle, everybody. And now we're going to continue indefinitely on both sides. That's the graph. Again, as far as I'm concerned, if you can do one complete cycle, you're in good shape, okay? Let's look at this one quickly. And by the way, you can ignore this graph it and then -1, take it down by 1 notch. That you can do, or just plot pairs. So here's what I'm going to do. First and foremost, I'm going to take the 4 out. I get 2 cosine 4 times x minus 3 pi over 4, which means the amplitude is 2, absolute value of 2. The t is 2 pi over 4, which means pi over 2. So a complete cycle should go from 0 to pi over 2 if there is no phase shift. But there's a phase shift of 3 pi over 4, so we need to add 3 pi over 4. So we move this by 3 pi over 4 to the right. That means you add it to this one, you add it to this one. Okay. So when I add it to 0, I get 3 pi over 4. Pi over 2 is 2 pi over 4, with 3 pi over 4 becomes 5 pi over 4. And now I want 4 sub-intervals. So I got to cut the t into 4 equal parts. T divided by 4, that means pi over 2 divided by 4, that means pi over 8. So you start from 3 pi over 4 to go to 5 pi over 4 by a factor of pi over 8, pi over 8, pi over 8. So it's starting with the first one. And by the way, let me just write it in this fashion so it might make it easy. This is the same as 6 pi over 8. And this is the same as 10 pi over 8. And I'm writing it in this fashion because I want to work with pi over 8. So this one, I'm going to add pi over 8, I get 7 pi over 8. Then I add another pi over 8, I get 8 pi over 8 or pi. Then I add another one, 9 pi over 8. Then I add another pi over 8, 10 pi over 8, 10 pi over 8 or 5 pi over 4. So these are the numbers I come up with. Again, I start with the first one, 3 pi over 4. And I add pi over 8, I get 7 pi over 8. Pi over 8, I get pi. Pi over 8, I get 9 pi over 8. Pi over 8, I get 5 pi over 4. So these are the 4 sub-intervals, everybody. So now I want to evaluate this function. I can evaluate this part and then bring it down by 1. You can do both ways. Or just evaluate it right the way it is. So let's erase the work. And let's start with the first number, 3 pi over 4. If I put 3 pi over 4 here, let me just write it down and erase it. The 4 cancels out, so you have y equals 2 cosine of 3 pi minus pi, 0 minus 1. As you know, cosine of 0 is 1, so this is 2 minus 1 or a 1. 1. 7 pi over 8. If I put the 7 pi over 8 times 4, I get 2 cosine. 7 pi over 8 times 4 becomes 7 pi over 2. Minus 3 pi minus 1. And this is 2 cosine of pi over 2, which is 0 minus 1 becomes minus 1. So we have 7 pi over 8 minus 1. Let me do quickly one more. Pi. If you put pi here, 4 pi minus 3 pi is pi. Cosine of pi is negative 1. Negative 1 times 2 is negative 2. Minus 1 is minus 3. So those are the pairs, everybody. Okay? You can easily figure out the pairs. And so now let's just plot those pairs. 3 pi over 4, 1. And by the way, y equals negative 1. I want to use that because one way is to graph this part and then bring it down. But I want to make sure that everybody understands the significance of that, which is in essence the horizontal line y equals negative 1. So 3 pi over 4, 1. So 3 pi over 4, 1. 7 pi over 8 minus 1. This is 1, 2, 3. This is negative 1, negative 2, negative 3. And this is pi over 4, 2 pi over 4, 3, or pi over 2, and so forth. Pi, negative 3, 9 pi over 8 minus 1, and 5 pi over 4, positive 1. This is one complete cycle. And now this is the sinusoidal function, and you go indefinitely on both sides. Y equals 2 cosine of 4x minus 3 pi minus 1. Again, the other method is very simple as well, and that means just ignore the negative 1, graph this. Basically, if you want to graph that, this just add 1. This becomes 2. This becomes 0, this becomes -2, this becomes 0, this becomes 2, and then shift it down. Either way is fine. Build sinusoidal models from data, steps for fitting sine functions into this, knowing one cycle. And so here's what happens. Step 1, determine A, the amplitude of the function. How do you find it? If you look at this one, the amplitude in this case, okay, was 1, the largest data minus the smallest data divided by 2, okay? 1 minus 1, 2 divided by 2 is 1. So max minus mean divided by 2. Determine B, the vertical shift is largest data, smallest data, add them up divided by 2. If you add 1 and -1, you get 0 divided by 2. There is no vertical shift here. So max plus mean divided by 2. Determine omega. Since the period is t, the time it takes for the data to repeat itself, t equals 2 pi over omega, omega is 2 pi over t. Finally, determine the horizontal shift of the function by using the period of the data. Divide the period into 4 sub-intervals of equal length. Determine the x-coordinate for the maximum of the sine, that has to be 1/4 of the way, and the x-coordinate of the maximum value of the data. Use this information to determine the value of the phase shift phi over omega, reminding you of this entire thing as follows. Y is a sine omega x minus phi plus b. You take the omega out. Amplitude is max minus mean over 2. B, the shift is, vertical shift is max and mean divided by 2. And period is 2 pi over omega. And phase shift is phi over omega. So we want to write an equation here where the amplitude is given, t is given, phi over omega is -1/3. So we start writing the formula a sine omega x minus phi over omega plus b, and we have to figure out the a, omega, and phi over omega. So because, and basically most everything is given. So because omega is 2 pi over t, we write, again, remember, t is 2 pi over omega, which means omega is 2 pi over t, so 2 pi over 3 pi. 2 pi over 3 pi ends up being 2/3, which means now we can replace the a with 3, omega with 2/3, and this one with -1/3. Negative in front of it makes it +1/3. And there's nothing about b. And so you're done. You can also write it in this fashion. If you put the 2/3 in, you get 2/3 x, 2/3 times 1/3 is 2 over 9. So both ways are acceptable. They may want it in this format. You have to distribute the 2/3 if they ask for this format. And by the way, what is b? B is not given, so you assume it's 0. All right. Draw a scatter plot and find a sinusoidal function of the form y equals a sine omega x minus phi plus b that fits the monthly temperature data for Indianapolis. Okay. So for example, January 1st, the temperature is 28.1 degrees Fahrenheit. February 2nd is 32.1 degrees Fahrenheit. March 3rd is 42.2, and so forth. So you do the scatter plot, and the way it works, this is the first point 1 comma 28.1. This is the second point 2 comma 32.1. This is the third point 3 comma 42.2, and the rest of it. So you plot that carefully, all those pairs, and when you do that, it looks like this. And so A is the maximum minus minimum divided by 2. So you look at the maximum value here and here, you notice we'll talk about the maximum and minimum, okay, to find the A. So you notice this is the maximum. This is the minimum. Maximum happens in July, which is 75.4 degrees. Minimum happens in January, which is 28.1 degrees. Subtract them from each other and divide by 2. And 47.3 divided by 2 is 23.65. Vertical shift is maximum plus minimum divided by 2. So now add them up, divide by 2. 103.5 divided by 2 is 51.575. T is 2 pi over omega. And since we are talking about monthly temperature, the assumption is they repeat every 12 months. So T is 2 pi over omega, which is 12 months. So omega is 2 pi over T, which makes it 2 pi over 12, which makes it pi over 6. Okay, monthly temperature, okay? So, for example, this January 1st and the next January 1st should be almost the same, or this, uh, you know, uh, September month and the next September month should be almost the same. So that's the concept. So as we look at this one, we have 12 months, 0, 6, 12. The maximum occurs 1/4 of the way. So if you divide the T by 4, you get 3. It should happen on number 3, the third month. However, the X coordinate of the maximum value, which is July, it's on month 7 instead of month 3. So that means it has been shifted to the right by 7 minus 3. It's supposed to be at 3, but it is at 7. See, 1/4. So phase shift must be 7 minus 3 over 4, pi over omega. So we're going to plug in A sine omega parentheses x minus 5 over omega plus b. And we're going to replace the A with 23.65, omega with pi over 6, minus 5 over omega with 4, and b with 51.75. Now, this is fine, but if they want you to distribute this, you get y equals 23.65 sine of, you put it inside, you get pi over 6 times x, and minus 4 pi over 6 or minus 2 pi over 3 plus 51.75. The number of hours of sunlight in a city on the summer solstice, the longest is 15.3 hours, and on the winter solstice, the shortest is 9.08 hours. Find a sinusoidal function that fits the data. So we follow that, and A is max minus mean divided by 2. So 15.3 minus 9.08 divided by 2, we get 3.11. Vertical shift B, add them up, divide by 2. So 15.3 plus 9.08 divided by 2, we get 12.90. So we're talking about a yearly situation. We assume there are 365 days. It's 365 and sort of 1/4, about 6 hours. So T is 2 pi over omega and it's 365, which makes omega 2 pi over 365. So plug in to this, replace the A, replace the omega, phi over omega, okay, and the B, and we get y equals 3.11 sine of 2 pi over 365 parentheses x minus phi over omega plus 12.19. And of course, note the value of phi can be found if the day and the month is given for each case by subtracting 365 over 4 from the longest day, as we did in the previous example.